9.3. Arithmetic sequences and series. Objective. Find the indicated terms of an arithmetic sequence. Find the sums of arithmetic series. Define arithmetic sequence. A sequence in which its successive terms differ by the same number d, the common difference. This is very comparable to a linear function. Example 1. Determine if the following could be an arithmetic sequence. So looking at the first sequence, we have -10, -4, 2, 8, and 14. Well, really what we're asking here is, could this be linear? So let's look at our first difference. To get from 10 to -4, you have to add 6. -4 to 2, you add 6. 2 to 8, you add 6. 8 to 14, you add 6. So yes, this could be an arithmetic sequence. Next one, 11 halves to 11 thirds to 11 fourths, 11 fifths, and 11 sixths. Well, to get from 11 halves to 11 thirds, you are subtracting 1.83 repeating. To get from 11 thirds to 11 fourths, you're subtracting 0.916. Right off the bat, I know, no, not a common difference, so cannot be arithmetic. The last one, to get from 2 to -5, you subtract 3. -5 to -11, you subtract 6, so we can say no, not arithmetic. The formula. General rule for arithmetic sequences. The nth term, a sub n, of arithmetic sequence is given by a sub n equals a sub 1 plus n minus 1 all times d, where a sub 1 is the first term and d is the common difference. You need to have this memorized, okay? I suggest creating flashcards or coming up with something to have this memorized. Example 2. Find the 11th term of the arithmetic sequence. -3 to -5 means we're going back 2, so we know that our common difference d equals -2. You might be wondering why I don't go through and test them all, and that's because I already know it's an arithmetic sequence, so I just need to identify what the common difference is, and I don't have to prove what it is. So to find the 11th term, we do a sub 11 equals the first term, which is -3, plus n, which is 11 minus 1, times the common difference, -2. So -3 plus 10 times -2, which is -3 plus -20, which gets us -23. So we know the 11th term is -23. Example 3. Find the missing terms in the arithmetic sequence. Well, we know that the fifth term, because this is, well, the first term is 17. We're missing the second, the third, the fourth terms, and we know that the fifth term is -7. So we can kind of use our formula to help us out. Remember the formula, a sub n equals a sub 1 plus n minus 1 times the common difference d. Well, we know that a sub 5 equals 17 plus 5 minus 1 times whatever the common difference is. Well, a sub 5 is -7, so -7 equals 17 plus 4d. Solving for d, we subtract 17 from both sides, getting -24 equals 4d. Then we're going to divide both sides by 4, getting us -6 equals d. So our common difference is -6. So if the first term is 17, going back 6, that takes us to 11. Subtracting 6 again gets us 5. 6 again gets us -1. And there's our missing terms. You could also use the formula as well to find the missing terms. Example 4. Find the missing terms in the arithmetic sequence. So using the same strategy in the last example, we know that our fifth term, 0, equals the first term, 2, plus 5 minus 1 times the common difference, d. So 0 equals 2 plus 4d. We subtract 2 from both sides, getting us -2 equals 4d. Divide by 4, getting us a common difference of -1/2. So we're at 2, go back a half, takes us to 1.5. Go back a half, takes us to 1. Go back a half again, takes us to 0.5. Example 5. Find the fifth term in the arithmetic sequence with a equal to 8 and, a sub 8 equal to 85 and a sub 14 equal to 157. What we need to do here is we're going to kind of alter our general formula for these arithmetic sequences. Generally, the formula is a sub n equals a sub 1 plus n minus 1 times the common difference d. Well, we're going to alter this. And we're going to say, well, we know a sub 14 equals a sub 8 plus n minus, now instead of n minus 1, it's now n minus 8 because we're using a sub 8 here. And then times the common difference d, of which we still don't know. Now, plugging in a sub 14, that means 157 equals a sub 8, which is 85, plus, now our n value was 14 minus 8 times d. So we get 157 equals 85 plus 14 take away 8 gets us 6 times d minus 85. We get 72 equals 6d, divide by 6. And we get 12 equals our common difference d. Now, you could go through and find the first term and use the original formula here at the top, but I'm going to use the one that I already created with the a sub 8. So I know if I'm looking for the fifth term, a sub 5 equals a sub 8, which is 85, plus my n value is 5 minus 8 times the common difference, which is 12. So we get 85 plus 5 take away 8 is negative 3 times 12. Gets us 85 plus negative 36. And that gets us 49. So we know our fifth term is 49. Arithmetic series. So the sum of the first n terms in arithmetic series is the product of the number of terms in the average of the first and last term. So here's the formula that you will need to memorize. S sub n equals n times the first term plus a sub n, all divided by 2. Find the indicated sums for the arithmetic series. I'm going to kind of split this up, that way there I don't take up too much space for one or the other. Okay, using our formula from the previous slide, and just to kind of refresh yourself on what the formula is, I'll rewrite it up at the top here. It's S sub n equals n times a sub 1 plus a sub n, all divided by 2. So the first thing we need to figure out, though, is what is a sub 1? In other words, what is the first term in the series? So we do 5 plus 2 times 1, which is 5 plus 2, which is 7. Then we need to find the 15th term, because we want to find the sum from 1 to 15. So we do 5 plus 2 times 15. 2 times 15 is 30. Add 5, we get 35. So to find our sum, S sub 15 will equal n, which is 15, times the quantity, the first term, 7, plus the last term, 35, all divided by 2. That gets us 15 times 42 divided by 2, which is 15 times 21, which gets us our final answer of S sub 15 equals 315. Going on to the next example. We first need to find our first term, a sub 1. So we have 50 minus 20 times 1, which gets us 30. Then we have to find the 15th term because we're looking for the sum from 1 to 15. So we have to do 50 minus 20 times 15, which gets us negative 250. Plugging it in now to the formula, S sub 15 equals 15 times 30 plus negative 250, all divided by 2. getting us 15 times negative 220 divided by 2, which equals 15 times negative 110, getting us our final answer of S sub 15 equals negative 1,650. And that concludes the lesson on 9.3.